Yeah. From Montreal, Canada, I'm Etienne. I'm the founder and CEO of Vention. For those that don't know Vention, think of Lego Mindstorm, meeting 3D CAD software, meeting Amazon Prime. How many of you have been exposed to manufacturing? Walked inside a manufacturing plant, deal with manufacturing processes, so roughly half the audience. So today I'm going to talk to a topic that is very dear to my heart and dear to a lot of us in the industry, is where will the unlock come from? Right? The industry is still pretty small in the world of industrial automation and robotics, and we know that most small, medium businesses have barely started to automate. So how are we going to change that? Right? So I'm going to talk about the 4 unlock that to me is the key to making this industry extremely big. And the first one is platforming and productization. So we shift away from an industry that is project-based with orphan machine and orphan code. The second one is digital twin and physical AI. So everyone can fully de-risk their robot cells and their equipment before spending a dime on CapEx. The third one, it's grayed out. I'm not going to talk a lot about it, but I'm going to leave you with a thoughtful question. This is about knowledge sharing. Think about the amount of manufacturing problem we've already solved, but for which the solution lies somewhere on a PLC or on a motion controller in a factory floor and cannot be reused by anyone else. Right? The software industry have cracked that several years ago, but that's a big unlock to think about. And last but not least, affordability. How do we bring automation so it fly under the fiscal year's budget, below 1 year payback? Right? So we'll talk about that, and we'll talk about how physical AI might get us there. So let's start with platforming and productization. To me, this is all the software suite you need to design your robot cells and automated equipment, program them, simulate them, deploy them so that digital twin is becoming a physical twin, and operate them with all the analytics, teleoperation, and so on. Today, if you're a system integrator, you need to learn a software to program your robot, a software to program your PLC, a mechanical design software to design the cell, another software to take care of safety. It's pretty hard. It's all disjointed environment where the data don't move from one to the next, context is to be repassed. So software platforming is to bring all of that in a single environment. But there's more to platforming, plug and play hardware. So you no longer need an electrician to deploy your automated equipment. Everything is connector based, like putting a keyboard on a PC, right? And with that, everybody can follow a wiring diagram, and everybody can be successful. So think of this as every hardware pieces that is compatible, Lego bricks, if they're available, they're compatible. 3,000 parts of this. And then you need to take your own dog food or eat your own dog food. You take the software, you take the hardware, and you create application. Highly productized application. And because they're so productized, they're highly reliable, they're super easy to deploy, and you can train operator very, very quickly as well. This is platforming and productization. Hardware, software, and application coming together to make industrial automation super fast and very easy. So anyone who's a manufacturing professional, not necessarily a control expert or a roboticist, can be successful at designing and deploying automation. And once you have that platform, it's time to inject AI. Not only physical AI, but also generative AI. What you see on the first pillar, I think we call that design and programming copilot. Anyone here has been exposed to Gmail sentence completion? It gives you the next few words. Think about this, but for robot cell design, where when you mouse over a given mechanical context, it just spit out the right part at the right place. You don't have to search in this library of thousands of parts. Right? That's generative AI applied to design. And obviously, there's more with generative AI. There's copilot, so when you program your robot cell, you don't have to learn all the codes and so on. The copilot is there to help you. And then you bring this to AI-ready hardware. So you can run those AI workload on the edge and open the door to autonomous robotics. And autonomous robotics for manufacturers is a little bit tricky. We know AI-based system for logistics and parcel picking have been around for quite some time. There's pretty good solution there. But manufacturers deal with sub-millimeter precision to grab and to place. And this is a much more complex problem to solve. So today we're very happy to announce the release of our AI operator technology, where we are able to grab unstructured part, full 3D layers of parts with zero training, below 5-second inference time, and reliability above 90%. And this 5 second is quite important. If I go back to 2016, 2017, there was vision system, but the inference time was around 12 to 13 seconds. You don't displace a human with that cycle time. It's too slow, right? You need to be sub 3-4 seconds to be able to move the needle here. And we're very happy to demonstrate that today. This runs on machine motion AI, this hardware, AI-ready hardware that I just showcased in the previous slide. I invite you to come see that at booth 135. Now, let's put all those pieces together. We have a platform, hardware, software, and application. There's AI-ready hardware that can run those workloads. How is the design of robot cell will change? Right? In a world where most robots get driven by a machine learning model, there's a lot of stuff that happen around the mechanical design and around the price of those cells. So instead of relying on complex actuator system, we'll more and more rely on simplistic robot arm manipulator because they're simpler and they're easier to program, even more with mission-based programming powered by AI. We'll see expensive, precise jig and fixture giving way to unstructured placement. You don't need them anymore. Instead of having hundreds of sensors to orchestrate your entire robot cells, you have just a few cameras. And the cost of camera is becoming increasingly cheap. And the AI model that now power those cameras make them just as good as a $20,000 camera. This is shifting. And last but not least, PLC, which has been the central piece of automated equipment and robot cell, will change. In that world, you need GPUs. And what's going to become the centerpiece of the robot cell will slowly evolve. And the robot cell of the future simply costs less. There's less stuff to build, less sensor, less jigs and fixture. So today, if we look at all of our portfolio of projects we realize for our client, on average, we're at 1.3 years. And I've been long enough in this industry that this is by all means outstanding. In fact, Europe is pulling us up. In the US is 1.1 year. So we're very close to going under the 1 year below payback. And that's going to be the last unlock, affordability. So all those small, medium manufacturers can also automate just like the high throughput manufacturers. That's what I had for you guys. Thank you very much.